Started. Hello, everybody. How are you doing? Hello, YouTube. I know YouTube's not a person. I know that, but it's hard to lump you all together any other way. I'm sorry. Hi, everyone. How are you
Hi.
doing? Hi,
Hi.
Ben. How are you?
Sorry, I was distracted sideways just trying to type in LinkedIn, the post to
Y- You're
let
you're
everyone know we've gone live.
multitasking.
Yeah. Yeah. I'm well. How are you?
Oh, it's been an automotive week here.
Yeah.
So let's talk
Yeah, I see
automotive.
that. You've written an article. So that article looks like from 2016, but it's got you call it a Datsun Z. In Australia, they were called 280Z or 280Zs because they were a
Zeds,
2.8
right?
liter engine, and those were super popular in Australia. I used to see them in a lot of places when I was growing up.
Right. And you probably saw them all rusty when you saw them. They were rust
Eventually,
buckets.
yes. Yeah,
Yeah.
Datsuns were known to rust out, but then again, most cars from the 80s and 70s, like,
They did.
it's actually unbelievable. We have really, people don't appreciate how much superior the
We
car
had this
coatings
conversation a
are now.
week ago with my wife. Yeah, how the metals are different than they were back then. You don't see mufflers laying along the road like you used to.
Right.
So I
And
used to say when I first moved to New Jersey, I used to say the New Jersey state flag should be a rusty muffler and a dead squirrel laying along the road. Because they were
yes,
just everywhere you went. Were those two things?
well, plus, you guys get those icy winters, so there's always salt on the road. And I
Yes,
think that's changed too over time. Like, correct me if I'm wrong, but I believe they use some kind of crushed
ash or
up
something.
pumice or something that has the same effect but is less rust causing for vehicles. Is that right?
I think here it's New Jersey. I think we still just use salt. We're not very environmentally conscious here. I've seen where I think they use ash, but I really couldn't speak on what they use. We haven't had snow here in the last 3 or 4 years worth anything. About 6 years ago, we got something almost 40 inches of snow in a week. My outside table looked like a marshmallow from the snow standing up on it.
Wow,
It was a
that's
round
cool.
table. Yeah, yeah.
Yeah,
So
like a big
the
wedding
snow had
cake.
landed. Yes, exactly, like a huge wedding cake.
Cool.
So
Dude,
it's
I've been so frustrated this week. It's unbelievable. I'm trying to buy parts for my hydrazine, and I'm using DigiKey's bomb tool. I'm using Octopart to look for parts. I'm using Mauser's bomb tool, and you know what? It's taken 10 months since the lockdowns. 10 months
for the
since
channels
the
to run out.
lockdowns for all the distributors to run out of stock and for their to be depleted. I ended up getting. I don't know if I talked about this last week. This
No,
finally
no. What is that?
this is an FT2232 breakout board which I got off AliExpress, and it's shipped locally. So someone's holding stock here in the States. Shipped domestically. So I got this really fast, but this is the only way I can get an FT2232 chip right now. I mean, it's crazy. So
So, are you
frustrating.
going to desolder it? Is that what your plan is?
No, I'm going to use it as it's designed,
As a
with jumper
Okay,
wires. I'll not solder that part onto the board. I'll just use, because I put the JTAG and the serial connections out to headers as well in case I needed to do this. So I was glad I
right,
thought ahead
right.
and did that. So anyway, that's
Yeah, if I had some of those, I'd ship them out to you. But I didn't have any stock in any 232s.
it's all right. I'm sure I could probably go on eBay and find some from some scalpers and pay twice as much. But
Oh, now I was going to say now the bad clones, right? Now
yeah,
suddenly they're worth something, right? Because you'd rather have a bad clone than nothing at all.
this
It's
might actually be a clone, but it does work. I plugged it in, and FT Prog recognizes it and everything. So I
right.
know it'll work. So I'm not too worried
Do you,
about
do
it.
you have any stories about how remember they started bricking drivers? If the driver detected it was an illegal clone, it would brick the application. Do you remember that?
Yeah, I do. I've never experienced that firsthand. I only heard about it when it was happening. Like, that was a while ago now. It was maybe what 8 years ago, or when was that?
It was
That
a while
probably
ago.
around 2013. Yeah.
6-8 years ago. Yeah.
Yeah. Yeah.
So hey, somebody
just
just
for those
asked
who
about.
don't know what
Go
Bill's
ahead.
talking about is, FTDI Chip is the British fabless semiconductor company that makes these marvelous and super popular FT2232s and FT232, USB virtual COM port and USB FIFOs, and this is the universal JTAG adapter used on many boards. So those chips are very, very expensive. Of course, they're like any popular semiconductor company. They want to recoup their R&D costs and then
Right.
make some profit on top. So the chips are not cheap. They're $8 each or something in single unit quantities. But back in 2013 or whenever it was, some offshore manufacturers, let's say, well, they're all offshore, but there were some clones that came out that were functionally exactly the same and even worked with the same software drivers. But FTDI had discovered this and found a way of bricking them. They updated their virtual COM port drivers to brick the chip if it discovered it was a clone. They had some means of testing that. Maybe they were all a copy of an exact silicon device that had its own serial number. So
Right.
any devices that had that serial number would be bricked.
Right.
Including
So Frank
the
Buss
one
just
unique one that was original.
right. Well, that's kind of like the old when somebody cloned an HDMI HDCP serial number. Yeah, they would brick all the serial numbers, including the original one.
Yeah.
So Frank Buss mentioned that Microsoft forced FTDI to remove the bricking code. So there was payback.
Yeah. Okay. So, yeah, that's tough, man. It's hard to. In this day and age, there's a lot of talented engineers in the world, and some people's sole job is to reverse engineer things.
Well, I remember seeing a picture of an of a die where there was 2 or 3 separate attempts to make the 232 on there, and then the one was bonded out, so you could actually see that they used the same die to try different reverse engineerings all on the same die.
Interesting. Oh,
Yeah.
That's really interesting. Yeah.
Yeah, and you could sit there and look at it and go, oh, they didn't even finish the third one, So, hey, before we get going, yes, the book is out. It is available through Amazon. They're asking about it on the channel here.
I know.
We self-printed from Amazon, so it saved us doing a Kickstarter. But if you hate Amazon, sorry, it's the only place to get one right now.
Wait, so what does that mean, self-printing? Because I looked into this years ago about using Amazon's self-printing service, but it looked very expensive to me. Like there wasn't a lot of profit margin in it.
There's no profit margin in it. As I say, we're paying for Bezos' space shot, off the backs of the book, and the ebook actually has even less margin in it than the printed book. So you think something that's just because it's Amazon, right? So they, and we didn't want to do a Kickstarter. I'm not socially savvy enough to have gone through all the Kickstarterness to really do a real publishment. So the other part of it is that the pictures are black and white in the book itself. They really lost a lot, but the ebook has color pictures. So I recommend buying both actually at the same time. So I'm being asked how to get signed copies. Right now, I'm not selling any signed copies like through herdware.com or anything. It's just a lot of work. But come to VCF East in October, and I'll be more than happy to sign a book. So and in a week from now, August 7th, we'll be talking about the book at VCF West. We're doing a remote session. And I'll be with Earl Evans from Retrobits. Margaret Morabito, the co-author, will be on the Zoom call. And we'll be talking about the act of making the book and then some stories out of the book.
Awesome. Hey, can you give us a sample, like story time with Bill and Ben?
Well, a little bit ago, I just happened to open it to the page called Bunnies, right?
Come on. Tell us the story.
Well,
Give us a sample.
you had to know Terry Ryan, the guy that wrote BASIC for millions of people, right?
Yeah.
Who claims to not remember doing it, right? And he's like, well, I don't remember doing that. And I'm like, you did, though. I have proof, you know? So he wrote the BASIC that's in the 128. Well, Terry is very cynical. He always had this smile on his face like he was waiting for you to figure out what he already knows, right? Like he's already got the world figured out. But outside, we were above MOS Technologies, 3 engineers to an office, and the offices are like 6 by 8, little bitty offices. We're on an engineer on each wall, and then the door on the 4th wall. So we're shoved in there like bunnies in a warren. Well, Terry hung a little picture of a little art sketch of a bunny rabbit outside his door. He said so he could find his door, so he knew which office was his. Well, one night, and I worked late, you know, I was young. I made 100 photocopies of that bunny. And I took the time. I mean, I took my time to hide all 100 bunnies in his office. And so he would be going through his Kleenexes, and a bunny rabbit would come out of the Kleenexes. 2 years later, we moved to Westchester. He opens a file and does something. He goes, bunny. And it's still a bunny rabbit. So that was the kind of thing we just did continuously to each other. In the book, I say that we used to cry a lot, but we would practice laughing so that when we needed to laugh, we could. We knew how. We hadn't biologically forgot how to laugh.
That's super important, dude, because you know what? In this whole last year, which, you know, I don't know about everyone watching, but a lot of people have started calling 2020 a dumpster fire, which is probably a good analog for it. But this is exactly like what people are missing. We're intelligent social creatures, and there are certain things you just will never get with Zoom or Skype or a GoToMeeting. And it's cool. It's cool working from home and everything. Like there are aspects about that, like not being stuck in traffic, and back to the auto theme of today. Like there are elements of it that are good, and a lot of us engineers, particularly people who like to find flow and concentration and don't want to be interrupted, and do the kind of work like PCB layout is a good example. When I'm doing layout, like the whole world could just go completely quiet.
And go away. Yeah.
It's like a state of meditation almost, right?
It's a Zen state, yes.
And not everyone finds it like that, but most people who are gravitated towards hardware design do. Right, so that's all cool, but there's this aspect of our lives that we absolutely need is connection, and that exactly pranks, harmless pranks, of course.
Interaction, yeah.
The whole let's charge up a capacitor to 400 volts with its lead bended over and toss it over the room to someone and say, "Hey, catch!"
Right. I had a teacher throw me a capacitor, and I caught it real funny. And then I looked at him and said, "You wouldn't throw a charged capacitor at anybody, would you?" And he said, "No, I saw you do that. No, I would never do that." But I caught it I was young, I had the reflexes, and I caught it in midair by the body, expecting it to be a fully charged cap.
Right.
Hey, so Frank, go ahead. Right.
So we're looking at your 280Z here.
Well, actually, I just to interject real quick. Frank Buss asked about BASIC. He said that's Microsoft BASIC. And yes, you get the copyright, BASIC message when it boots, right? Yes, we started
Z80
with...
Right?
What's that?
That was the Z80 BASIC when you booted in, because it could boot into CPM, but wouldn't it run the Z80 BASIC as well as the 65H BASIC?
No, it only ran CPM. Now, the Z80 would wake up first, but then he would do some house cleaning. Then he would fire off the 6502 if it was appropriate to fire off. He would look to see if it needed to be in 64 mode or 128 mode or whatnot. But the BASIC originally came from Microsoft. And the story is, I've seen Jack Jamil. He talked about this at the anniversary of the Commodore 64, 25th anniversary, long time ago now. Obviously, Jack was still alive. And... what's his name? Jobs wanted $1 a copy or something for each BASIC that went out in a Commodore computer, and Tramel's answer.
Bill Bill Gates.
Bill Gates. Who did I say? I said Jobs. Bill Gates. Yeah.
Yeah.
Don't listen to me. So he and Tramel's response to that was, "I'm already married," right? Meaning he didn't want to be in bed, having to pay $1. So we bought Basic for $15,000, I think, something like that, between 5 and 15. It was a lot of money back then, but we owned the right to do Basic. But then the Basic that's in the C128 and in the Plus 4 is not Microsoft Basic. They completely scalped it out and rewrote their own Basic. So Terry Ryan really did write Basic using, he replaced every module. By the time we were done, there wasn't any Microsoft code left in it.
It's kind of like the Commodore version of BSD.
Yeah,
Like
yeah.
The guys from Berkeley had, by the time they'd rewritten 99% of Unix, they're like, wait a second.
Yeah,
We don't have
we
to
now
call
have our
this
own
Unix
version
anymore. Well, let's just finish that 1% and call it BSD and open it up and create industry. And it was really good. They actually made careers and businesses happen because they opened something up with a commercial-friendly license.
Yeah. Yeah,
But
well,
this is what I kind of don't like about, I'm not against open source. I'm not really against GNU licensing.
Right.
But I would always prefer something more like an MIT license or a BSD license, because I think it's actually better for people to have a career and have it's better for business just to be able to package something up, use it, and not necessarily be obligated to add everything you do with it back into the whole community. I mean, I get it, but it's kind of it's a different kind of oppression to be forced to give every add-on you do back in every case, and it doesn't always make sense. Anyway,
Right,
I'll stop my rant.
Right. No, I started my ISP business in 1995 on BSDI, right, which is a paid version of BSD. And I wanted to pay money. I wanted that support. I wanted to know, and Linux was very fledgling, and it was like the versions were like Yggdrasil and those versions of Linux, the real old stuff. But they would break the kernel to fix the audio driver, and I'm like, there's no audio drivers on my server. Just give me BSDI, and it costs $4.99 to run my server. For my original Zeus was his name back when you named your Unix servers, right? So it was Zeus.
How many Zeuses do you think there were on the internet in those days?
Oh, probably tons. Well, when we started, we had to support Gopher a lot. A lot of people used Gopher when they got on the internet, as the markup language was still version 1. It didn't even have background colors when we first started, or background images. So yeah, I'm going back in time there. So yeah, the news server's name was Hermes, the messenger of the gods or something. Yeah. So I had the not UUCP but Usenet News.
Oh, yeah.
You were rated how good an ISP you were by how big your hard drives were in your Usenet News server.
Wow, that's way back.
Yes.
I remember getting on the internet in 1993 when I was in my first year of college. And the internet was brand new, and they had this one or two desktop computers in the college library that were always connected, and you could book time on them. And I was going to Alta Vista every day to look up component data sheets, because I discovered
Alta Vista came along after 95, I think.
Digital Equipment Corporation hosted Alta Vista, and it was the search engine, and it wasn't even a search engine. It was just a link crawl. They'd put a database, they'd developed some kind of link crawler and made a database, and it was the best. Back then, the internet was only known and used by really technical people for the most part.
Right. And you weren't allowed to advertise. You weren't allowed to make money off the internet when we started.
Right, so there was all this information available, and most of the companies that were connected and offering information for download were just companies like Texas Instruments, and they were starting to put all their data sheets online. and it was just the coolest thing. So anyway,
So now when I started, there was no Alta Vista, but there was an Archie server. Do you remember the Archie protocol? You would log into a server. In my case, the closest one was in Nebraska, and you would submit a search query, and it would take 30 seconds to a minute to come back because you'd queue. And it would come back and say, oh, I found a thing in Florida, and here's a link for a thing here. And so we had to use Archie to do searches back before Alta Vista or Yahoo or any of those. Do you remember when you had to use bang paths to send an email? Do you remember a bang path? Do you know what that is?
Well, with exclamation points in it? Is that what you mean?
Yeah, so you couldn't just send an email based on the destination. You had to tell the email how to get there. So next to the terminal was every email address known to mankind that we knew of, right? And you would have to say, okay, somebody's name, bang, cmu.edu, the Carnegie Mellon.edu, bang, smcsu.edu, bang, somebody else, bang, and you would
actually tell it which route,
which hop to take, and it would take a week to find out the mail didn't go through, because the response had to come back. And so we're doing it in batches. We used to use something called UUCP, which would dial in, download a bunch of email, it'd dial in once an hour or something like that. And so it would slowly make its way from those different computers doing that. Yeah,
because they'd all have to synchronize, and they were paying by the minute for the phone for the extra time. And it was expensive back then, and crazy stuff.
Now back at Commodore, we had Zilog Zeus boxes. There's that word again. Z8000 based Zeus boxes. And so a guy named George, we call him Grr, Grr. That's the way he wrote his name on everything. He ran our UUCP server, and his motto was "Little Unix boxes that take over the world." Yeah, so it was a cool time. It was a cool time.
So tell us about your 280Z. And
I got my Datsun working this week. I needed to fix my garage door opener, which was directly above the car, and the car has been parked for since before the pandemic. And I needed to get it out of the garage, so I had to start it. And I did this week. It actually ran, and this thing's a monster. It has been mega squirted, and by that I mean I replaced the ECU. And here's an article I wrote for Hackaday back in 2016. Wow, 6 years ago. 6 years, yeah. And hang on. Here's what the engine looks like. I had this engine completely out and rebuilt and then put back in. I've already started to forget what some of these things are. But they're air regulators. This big blue thing here is a fuel rail.
Right.
The original,
injectors.
The original fuel rail in a Datsun was prone to vapor lock, which means it got so hot from the engine underneath it, it would build up gas vapors, and it would keep. It wouldn't allow the gas to flow smoothly through it, and you'd have to let the engine cool before the engine would start again. So I put in a extruded frame rail. All of this blues and reds, those are either anodized fittings.
Custom. Yeah, it looks custom.
Yeah, or powder coating. So I have a oven in my garage.
Oh my gosh!
Where I learned to powder coat.
Is there anything you have not done?
World peace, all that. So
Dude,
so I built a kit called a Mega Squirt, and here's the kit, and it's like based on like an old 68 HC11 or something like that. It's an old Motorola microprocessor.
There's been a number of 68 HC11 based custom ECUs out there. I saw one, and I was sharing this with you before we got talking. I started researching all of those too, because when I married Erin, my wife, she had a 86 Toyota Supra, and we had to go through some of this stuff with that as well. We didn't have to. I chose to, because
you chose to. So you went through this phase too of carring, right?
Yeah.
Right. So actually, it says right here in the article what the processor is. I had forgotten what it's actually an MC9 Sierra 112 C64.
But I'm
whatever
sure
that is.
That's got to be some derivative of a 68.
I think so. Yeah, that's
11.
probably why I'm calling it that.
Those were 16-bit, right? Or MC?
Yeah, this is a 16-bit.
Yeah. Cool.
So it's and these TO220 cases you see here, some of these are the actual injector drivers that pulse the injector open and closed. There's all kinds of things going on here. Hang on. So if I scroll back a little bit, so I talked about air through the engine and what it means. And in the original Datsun, there's this flapper. Air would pass through this device right here, and this looks like a potentiometer right here. Well,
yeah,
basically
it does,
is. So this would flap open and closed. So it resists airflow, kind of. If you think about it, it's in the way of the air. Yeah. On the left is a MAF. I forget what MAF means. Mass airflow sensor.
Mass airflow. Yeah.
Which is the heated wire technology.
Right.
Basically, they heat a wire.
Yeah.
And this is why I have in my BMW. They heat the wire, and then they measure how much heat gets lost off the wire by its conductivity, I think. It's been way too long.
Yep.
So, but the way the Megasquirt works is it uses a barometric sensor. And it measures the air pressure in the manifold, and from there it draws a fuel air map. So it took out the whole airflow sensor out of it.
That uses a MAP sensor, which is manifold air pressure,
right.
Those are used usually when you have a turbocharger, from what I understand.
Which I have a turbocharger. I have a big turbocharger in this thing.
Whoa, cool.
Yeah, so now part of the story is I took a Datsun 280ZX. I made it into a manual. Hang on, let me get this out of the way here a second. So I made it into a manual transmission. I love manuals, right? You probably do too. We're from the day.
Well,
I mean, in the Army now.
It is a manual.
Yes.
It's a 1.6 turbo. It's a very zippy, fun car to drive.
Right. And in the Army, we used to have manual transmissions in Jeeps because most people in the Army were from farmers, World War II and stuff, knew how to drive cars like that. And now Hummers and all those Humvees and stuff, they're automatics because people really don't know how to drive a manual anymore. Well, I'm a manual person, so I took out the transmission out of the Datsun. I put in a T5 Mustang transmission. I had to get a custom drive shaft because now the length has changed because the transmission's a different length. And unfortunately, it dawned on me.
How did you fit that into the body, under the car body? There's the metal of the car body pressed into a certain shape. How do you make sure there's room?
It fit, but I had to make my own brackets to mount the transmission.
That's astounding that it just easily fit.
It was known that you could do that, but because it was a ZXT, I'm the only guy a 2+2. The length was different, so I had to get a man. I'm the only person I know to do the conversion to a 2+2 ZXT, and so I had to get a custom drive shaft, crankshaft, drive shaft to now fit that difference in length. And then I was sitting there thinking that there must be a bracket for the clutch pedal already under the dashboard. I just assumed that it would be there and where they nope. After I'd already put all the dash back in, there is no bracket for the clutch pedal, so I had to lay on my back, upside down, welding above my face, and I hate dropping hot metal on my face, I just do. But I put in a whole clutch pedal after the car was finished on the inside, and it's a running manual transmission now, so it all worked out.
Dude, this is the whole side of you I never knew existed. This is complete, like today, I never pegged you, I never would have pegged you as being more than just curious about
right.
electronics for automotive. This is mind-blowing to me. That's what I say. Like, is there anything you actually haven't done?
I don't know. So you know what this is here, though, right? You used the words earlier. This is the fuel air map for the car.
Yeah, I see that. All right, so the blue area is where it's super lean and low revs because it's just idling. Is that correct?
Yes,
and
yes.
And the red is, or as it goes pink, is where you get rich and you're in high output
Right.
Or what's
And
the deal there?
yes, no, you're absolutely right. And as you're idling, this block moves around the field, and so there is a wizard that I could run that would and this self-learning ECUs do this. I had to do it with a laptop running something called Tuner Studio Analyzer or something like that, and it would learn to do things like when you first let off the gas. If you're on the gas and you first let off, it would go super lean to burn off any deposits on the spark plug. So there's history mattered a little bit, is what I'm trying to say. It's not just about the pressure and the fuel and stuff.
Right, but then I heard also, like, especially with a turbocharger, you can't run too lean because
You'll detonate. Yeah.
You'll
detonate.
Starts detonation and things like that. And when we were working on our Supra, before I had kids,
right.
We followed Reg Reamer, this Canadian guy who took the 86 Supra, which is the lighter, more angular, cool 80s looking one, with the pop-up headlights, and you put the older car, which is smaller and lighter weight, that with the newer Supra engine, which is switching a 5MGE engine out for a 7MGTE. And then I had to do the whole wiring harness, and that experience was so expensive and painful, I decided cars weren't my thing. But it was fun to drive once we were over and done with it, because it was so much more powerful than the previous engine. The car no longer felt like a boat; it felt like it should have felt, responsive. But in all of that, I remember the engine rebuild guy who helped me install it, saying you got to be super careful not to run lean with a turbo, because he says you'll end up with parts of turbo impeller in your exhaust.
Right.
Not just in the exhaust, because the turbo. What he meant was you'll end up with bits of your turbo compressor inside your cylinders.
Right.
If you run lean.
Right, which eventually make it to the exhaust in a true catastrophe. Yeah. So what Ben's talking about is there's an ideal. How do you say the word
stoichiometric fuel ratio?
14.7, if I remember right.
Yeah.
Is the ratio.
It's weird, the things we mentioned. I'm not even into cars. Like, I claim to know very little about cars and engines and how internal combustion works. I'm not a mechanical guy at all. But I learned enough through that one experience that it's weird.
And that's where I'm at. I restored this car, and so I learned everything I know about cars from this one car. Yeah.
Are those the gauge panels we're looking at from the Nissan?
So this is the software that I ran on the laptop, where I set things like priming pulse width, where it primes the engine when you first turn it on. And here it says warm up enrichment curve. The warmer it gets, it puts more fuel in when the engine's cold, basically. Okay. And then as the temperature comes up, it starts coming off. So a lot of things. So in addition to the fuel map is all these other influences, like, well, is the engine cold? Do I need to prime the injectors to even start the engine? And it's my engine has a little trouble starting after it's warm. It's actually backwards. If it's cold, it starts easy. Once it's a little warm, I have to kind of pedal it a little bit.
Well, this is interesting because these are all examples of, in engineering in general, multi-input, multi-output control systems. That's essentially what we're dealing with here, because your fuel map is a three-dimensional part of this, but then you have all these other factors that come into it as well. You've got temperature, you've got current speed of the engine, you've got output power. All of these are parameters or variables in the state space of the system.
Right.
And being able to translate things from mechanical to state space equations and variables is a key engineering skill if you're going to be a controls engineer or systems engineer. And what does that equate to? It equates to the code and the tuning of the code you program into your real-time processor system. So it ultimately comes down to software, right?
Yep.
And even in a 1980s car, this stuff used to all be done with mechanical things and mechanical feedback loops. But now it's the ball's squarely in our court as embedded software people.
Right. So do you know how it was adjusted? How the dwell angle was adjusted back before there were ECUs?
No.
There was a vacuum line, so the manifold pressure still mattered, and the manifold pressure is how much load is on the engine.
Yeah.
You would run that to the carburetor, and the carburetor would actually rotate a little bit in there and advance the spark the faster the engine was running.
And that was all based on the vacuum pulling a thing. So
yeah.
Wow.
Yeah.
Don't ever ask me to troubleshoot an engine. It's not my gig.
Well,
no, but these gauges. I was asking about these gauges on your desk because they look a lot more modern than an '80s Nissan. The gauge panels on your desk.
Yeah. I was going to get to that. They're from a different car altogether. These are from my BMW, which I also worked on in the last week.
How many cars do you own, Bill?
Total of 3. So I've got a BMW. Okay, so the BMW is a 1998 M3. That's my performance car that I run around in.
That would be fun to drive too, I'm sure.
And I have to find home for the Z and the M3. So if you're looking, make me offers, everybody. So, but the M3, I redid it. I should post pictures of it on here sometime. It was done in that brown burl fake wood trim on the inside. It was black and brown burl.
Yeah,
right?
I remember they did it. I bet it has like an 8-speaker or 12-speaker sound system in it too. Like BMWs always were so advanced with that kind of interior comfort, soundproofing, all that stuff. They've been
but the M3 is a little more basic than that. But I hated the burl, so I redid my whole interior in silver and black. So I took off the airbag and stuff and painted it silver. Using vinyl spray paints. I forget not Krylon, but there's a brand of very good where you actually prep the vinyl or prep the plastic, or you can spray rubber in some cases. There's a flexible flex additive that you mix in with it. And so I redid the whole interior in silver and black. And so to go along with that, I put in these EL gauges that you see here. Right? So they had a blue-green glow, and I set it to blue.
And you can hear them. You can, if you put your ear up real close, you can hear the inverter going.
Yeah.
So I never about 1,000 volts at 1K, right?
Yeah. I know it's above 300 at least, right? So the problem with those gauges is that if you expose them to ultraviolet sunlight for 10 years, they stop working.
Well, that sucks.
Yeah, it really did, because I got my M3 running again and everything, and I had no dash gauges, no dash lights. And it really did suck a lot. And I mean, I'd go to sleep at night going, I got to tear out the dash on the BM3. There's no way to get the dash cluster out without removing the steering wheel, which means you have to remove the airbag, which you better know what you're doing when you do that. Hint, disconnect the battery for at least half an hour, right? You got to let the capacitors discharge. And the only reason I know that is because I used to be an EMT, and we talked about how to clip the battery cable and how not to set off the airbag right in the patient's face. So, a little bit of training on that. But I had to take the airbag off, and of course they're all torque screw protected. Yeah. Take the steering wheel off. You better know how to put it back on so you drive straight. And then take the cluster out, more torque screws. And then I had my son help me. We put it on the bench. It took 45 minutes to tear this cluster down all the way where I had to take the needle gauges off, everything, the needle dials, and pull these things back out of the cluster. And I had new ones. I just didn't. These are actually the new ones sitting here. You can tell because they no longer had the BMW brand on them. Because
I see they're aftermarket.
They're aftermarket,
still right? So you can plug them right in. That the inverter is still working.
They would have worked. Yeah. Right.
So
but I chose not to.
They'll be done.
Right. So I chose not to do. My original ones actually had the M logo, the M3 logo on the EL part itself, And so I talked with different EL guys that I used to use, and they're like, nope, BMW tracked down on us on eBay and whatnot. So they couldn't sell it with the BMW logo anymore.
Bummer.
So I chose to take it out and just put it back to stock. So now I'm back on my stock dash lights in my M3. So that's my automotive stories for the week. Let's see if there's anything else here. Yeah, so the final thing was this Mega Squirt tuner kit did have an interface for things like you could create your own speedometer here, like this. Let me make this bigger. And you could even put it onto an iPhone or something like that if you wanted an electronic dashboard. You have the tools to do that. The problem is, I'm waiting now for the ECU to die. If it dies, it's like, oh, do I really? I don't even right now, because the laptop actually died. I don't have a backup copy of the ECU map. So no. I'm going to have to build another laptop, log into this thing, and make a backup copy of the.
It's not going to die, and it still would work totally fine based on how you previously programmed it. I think. If you sell the car, whoever buys a car with those mods is going to be someone who knows what to do and can get into it and make it.
Or they restore it to what it was.
To do that and look at the map and do all that stuff themselves, because they'll be that kind of person.
Right. Well, that's it. Anybody that's really into automotive electronics, give me a shout. We'll. So. Yeah, again, you see how old the technology is. That's a 10-year-old ECU board. The laptop failed because of the battery, but.
And even though that's a 10-year-old ECU board, that was even 10 years ago. Everything else in the world was already surface mount and,
right.
BGAs. I mean, that ECU board is probably from a mid-'80s design.
Yeah.
Right.
Yeah.
But with the module, the modification module with the microcontroller is mounted where the original 40-pin microcontroller used to be.
That's it. You see that the SMT part is the MCU board upgrade, and it's the SMT. Everything else was all through here. And then here's a little circuit I put in. For example, this is the detonation sensor. It takes an ultrasonic sensor and starts to detect if you're getting into detonation, and it will retard the spark a little bit.
Oh, that's cool.
So there's even a little zone here for your own circuitry and stuff. I have a whole 3-ring binder just for my car, right, to operate the car.
So whoever buys it's going to get the binder, and they'll have all the details.
Oh, they'll get the binder and a full walkthrough and everything. Yeah. So I'm just after a good home for it. I'll never get my money back out of it. I don't even want to tell you how many thousands of dollars are in this dang car. So
yeah.
Hey,
it's
so you were talking
tons of money.
You were talking earlier, though, about IPCC training in automotive. Do you want to talk about that a little bit?
Oh, well, just the subject of automotive reminded me that, I'm a CID Plus certified PCB designer. So what that means is, I'm an electrical computer systems engineer, first and foremost. I did go to university, but I realize there's value. No one in any degree program at university, generally speaking, no one will teach you how to design PCBs properly.
Right.
They'll assume that by studying electromagnetics at undergrad level, by studying electrotechnology and other aspects of hardware, and you'll do schematic drawings and you'll do SPICE simulation for labs to learn circuit analysis. And you'll do all that, and they'll assume that by doing all of that, you'll synthesize this knowledge that leads to how to design printed circuit boards. But there's so much to it that you don't learn unless you actually take it on as a serious role or decide to. So the IPC CID program is an industry certification that basically walks you through all the practical aspects of printed circuit board design. And a lot of it comes down to where is the product used? Is it going to be mass produced, or does it have to be highly reproducible? Because a lot of the issues around circuit board design are about how easy is it to make this board, and the cost of the board comes down mainly to number of lamination cycles in the factory and how much scrap they have to discard. So if
Right,
you
right.
design something real cutting edge with a lot of blind and buried vias and red layer registration's important, you might discover that the only boards that come out of the fabricator correctly are the ones in the very center of the fabrication panel, and all the rest on the outside, they'll do the testing on them and discard 90% of them because they're not going to meet your specification. And you could wonder why. Oh, why do I go to JLC PCB or PCB way? And as soon as I go to 8 layers and blind buried vias and HDI, suddenly it's horrendously expensive. It's not necessarily all because it's not because it's it's not because it takes more time and labor to make the boards. That's half of the cost add. But the other half is the more complex you make things, the more scrap there is, the more of them won't work. So it's about manufacturing yield. And so you have reproducibility levels. And the first thing you learn in the CID training is how to classify. There's actually an IPC standard for it, and you can specify it when you send your manufacturing documentation off to get the boards made. You have to communicate clearly to the fab, this is what we need. We know, and you've got this language to communicate to your management to say, well, what you're asking for we can do, but it's going to cost more, and this is why. And so they talk about reproducibility. How hard is it? How much scrap will there be? How hard is it to make? Or then they talk about and that
Durability.
ranges from okay. There are some things where we can be real loose with our standards. We don't mind a bit of via breakout where the hole's off the edge of the via, because maybe what you're building is a simple, the example the instructors always use is a gift card that you open it and it plays a tune. You're going to make millions of them, and they're very simple, and they have usually only one layer of copper anyway, and a wire bonded chip, and there's not much that can go wrong with them. So the board itself is dirt cheap and simple, and you can have all sorts of variants in it, and it's easy to make. And the other extreme, the most harsh environment of all the environments you could think, there's aerospace, there's shock and vibration, there's outer space like low Earth orbit and beyond, where you've got radiation, and you've got vacuum, hard vacuum, and you've got intense temperature variation between light and dark, and that's pretty harsh. But the harshest environment classified by IPC is, guess which one?
Automotive.
Because you're dealing with hot, cold, down to sub-zero. You're dealing with dirt, grit, vibration,
moisture,
and chemicals. You've got the magic combination of everything that's horrible and nasty under the hood of a car. And this is another good reason, I guess, why we're going to electric vehicles. The range is still a problem, and I think we may have an issue with how much lithium is available on the planet to turn into batteries.
Yes.
Because lithium, it's not like there's not a lot. It's not as rare as gold. It's not as rare even as silver. It's just very hard to extract it all because it's distributed, right? So you have to go through a lot of dirt to get what you want.
Right.
So, yeah, these are problems engineers need to solve. We need to solve the problems of energy density, recycling, all that stuff.
Right. So I'm wearing my EMS shirt today, just out of luck, right? And so you just reminded me of something. Like, they trained us about airbags, right? And it was funny because the guy said when he got trained, my trainer, it was like the automotive manufacturing people said, oh, airbags are safe. We would never put something dangerous in a car. And they raised their hands and said, well, you put gasoline and sulfuric acid and these other things in a car. So don't tell us there's nothing dangerous in a car. We live this world. So what I am not trained to do, because it is new, is how do you put out an electric car fire? And I've heard it described as a birthday candle that keeps reigniting those
Oh wow, yeah,
joke candles that you blow them out and they reignite.
yeah.
So, and lithium hates water, right? So how do you put out a car fire? And this is going to be a problem. I think we're going to have some people die before we figure out,
And so the powder extinguishers aren't good enough.
Fire engines don't carry. I mean, they have the extinguishers, but the tanker's full of water, not powder. So, and I am not a fire
really
guy.
Big fire, then.
Yeah. How do you put out? Because we used to they pop the hood and put a hose under it and stand there and smoke a cigarette. I mean, they're so nonchalant about it; it's not even funny,
Never mind that you're spreading the burning liquid. Gasoline.
Oh yeah,
oil.
it hazmat.
It's floating on the water as it drives. It goes away.
Right. Yeah, and I'm being semi-facetious there, but yeah, because we really aren't allowed to just dump oil and gas into, which gets absorbed into the asphalt. If you have the wrong kind of spill, they're supposed to come behind and tear up the asphalt and put down clean asphalt, because in theory it soaks into the asphalt.
Yeah.
So yeah, I'm waiting for this whole where we catch our breath in the electric vehicle industry, and really deal with fires. So somebody will be trapped and they won't be able to save them because the batteries are on fire in a way we can't put out.
It's going to be the lithium batteries burning. That's the problem. Yeah.
And I've been on calls where we got people trapped. It's suddenly the nonchalance goes away. When there's somebody trapped in a vehicle, even the most seasoned people, we would get tense. We get that look on our face.
So you've seen it where someone's trapped in a car, but there's a fire.
Right. With smoke involved. Yeah, evolved into
the cabin. Yeah.
Oh, the whole cabin was smoke.
How do you respond?
Oh, we blew the windows and pulled them out. I mean, we weren't dicking around.
Yeah.
Normally we put a board behind them, support the spine and all that. No, we didn't dick around when that one went where the whole hood of the car caught. Yeah, we didn't.
This is why
they were kids.
We carry. My wife bought these things. The window smashers. We carry them in every car.
I carried those for so many years. The punches, right?
Yeah.
It's
a chunk of metal cone that goes down to a point that'll break the car glass.
And what I used to carry was they have those center punches where you press them and then they click. Yeah, I had two in my turnout gear because one time nobody had a frickin' center punch. And we had to use an axe tip on it, and that sucks. You put an axe tip and hit the axe. And there's a patient right behind the window, right? So how do you blow a window? And we've also done where we tape the window and hit it so it doesn't splatter and stuff. But that's only if we have time. A lot of times we're in a balanced situation. Yeah. Where the car's in a precarious position. It gets hairy. So no, I carried those things for years. It was kind of like my safety blanket. Even my civilian clothes, you'd see a center punch, and I didn't know that they're real center punches. I thought they were made for us to blow windshields with. It wasn't until I was at Harbor Freight one day, and I'm like, "Oh, center punches! I get it now." Okay.
Cool.
So
that's good stuff, man.
Hey, so. One of the things we talk about from time to time is DFM, and I posted during the week on Discord, hey, anybody got any good DFM sites? I didn't see if anybody answered. But you mentioned HDI. You want to close up today talking about what HDI is?
Well, I hadn't really prepared anything, but we can.
I know. I sprung this on you here. But
it just stands for high density interconnect. But what it means is... it's just a simple classification. There's two things, not to be confused with microvia, but usually HDI means there's microvias. But a microvia technically is a via that its aspect ratio is less than basically
a certain amount.
Yeah. So if the via depth through the board is more shallow than its width, it's classified as a microvia.
Okay,
which is odd because it could go all the way through the board and be a big mounting hole. And so it's like, well, we know, like beyond a few mils in width, it's
right.
at that point we'd call it a blind or buried via if it was blind or buried. But HDI just means you're dealing with micro vias that are roughly less than 5 mils in diameter, typically less than 4. And
so is via in pad automatically considered to be HDI?
I don't think it is by IPC definition. I'd have to go and check the standard. But people consider it such. So,
I do. Yeah.
So, if you're, and here's the cool thing, if you're doing via in pad and they are micro vias that only go down 1 layer, or maybe 2, but you have very thin dielectrics, you don't necessarily need to fill and cap them, right? So if you have a BGA package, and the ball is going on a surface mount pad,
right?
That ideally you want a perfectly flat surface for that solder to stick well, to stick to and wet to, and grab onto. And the BGA balls actually even reach around and grab onto the sides of the pad. So you imagine the pad, if you
a fillet, a wetting fillet.
Pad, the edges of it are almost like a mushroom shape, right? Because of the way the plating and etching processes work. And so a good BGA wet bond will reach around and wet even to the sides and grab on. But if you have a very, very shallow microvia that's under a BGA pad, if your dielectric layer is thin enough, I've seen plenty of and spoken to plenty of people who've designed boards where they didn't even bother because the via was so, maybe it was only a 2 mil via or a 3 mil via diameter. It was such a tiny dimple in the surface of the pad, it didn't matter.
Ah, okay.
So,
what about gases trapped in the via? Is that ever a problem where once you hit the soldering cycle, you get like that expansion of the gas that's in the via?
Well, that's a problem when the via is big enough to harbor.
Right.
And it's harboring water and flux at that point, and those have to get out while it's in reflow. So, yeah, that's why with larger buried vias under BGA pads, you have to fill and cap them.
So, talk about fill and cap. What's involved with filling and capping?
Well, the cheapest way to fill and cap normally is they squeegee epoxy over the board. All right. And then they do another polishing pass to re-expose the copper of the pads. But so you can imagine you've got the pad.
You end up with a slug of epoxy then.
Just a slug of epoxy in it, and then they plate copper over one more time, and it plates all the way over. And so that's very expensive.
Right.
And cost is the real deal with HDI. Yeah. But if you want to learn more, you know what? There's one particular manufacturer that has the best, in my opinion, the best. There's a lot that have good info, but the best one is Sierra's website. If you go to protoexpress.com, I'm not affiliated with them. I just know, I do know those people, and they're good guys, but they've provided a lot of really good resources that explain all this stuff on their website. Right. Perhaps more than a lot of other fabs. I guess they understand what content marketing is. Let's put it that way. But the content's good. It's worth downloading.
Right.
So
now, have you ever done chip on board yourself?
No.
That in the early days, that was like, that was our holy grail for density. We would do flip chip on board, and whenever you see that little splock of epoxy, there's a naked die under it a lot of times.
I've had customers that did that in pace. I remember going to a place where they were designing pacemakers, one of the well-known pacemaker manufacturers doing chip on board, and they have partially was flip chip, or they were transitioning to flip chip, like the silicon with BGA bumps on one side soldered directly to the board, and then encapsulated in epoxy. But they also their prior product was wire bonded. And I remember this is years ago now, one of our FAEs, Rick Wilson, who was it Rick? I think it might have been Rick. Someone wrote a script in the CAD tool to generate the wire bonding outputs, and so they would use an extra mechanical layer in the PCB editor.
Okay.
To draw lines to model where the wire bonds had to go, and then generate a text report out of that to a CSV file that would say, this net, this wire length, this start point, this end point, and they could feed that into the wire bonding machines.
Bonding.
So,
yeah. Very cool. Well, hey, that brings us up to the top of the hour. How was that for filler material for the last 10 minutes?
Yeah, Frank's saying chip on chip. That's right. That's where hybrid actually went. Chip packaging went to that 3D, they call it, but really it's 2.5D, because they're stacking. TI did that with the Stellaris microcontrollers, and you could buy the older Olimex boards that use the TI Stellaris ARM chips. Those were that generation that came out about 10 years ago, where they had the microcontroller goes on the board, and then the package of the microcontroller is a VGA on LAN pattern on top of it, and you put the DDR3 chip directly on top of that. And I guess those were developed for mobile phone business, but they've found their way into other embedded systems too.
Right.
Yeah.
Right. Very cool. Very cool. I'm all talked out. Any final words?
Flippity gibbet. I don't have any.
And that's a type of technology where they bond wire bonds to each other and then flip the whole thing all together. So it's excellent.
Hey, Bill.
Well,
yeah, good to see you again.
Good seeing you again, Ben.
Already. I feel like time just is. I feel like saying stop the world. I want to get off some days, because the weeks are going by too quickly, and I have too much to do and not enough time. And but it's always good talking with you.
Yeah, and I'm at the age where I only have a certain number of days left, on the calendar, and so when another one goes by, you go, hey, that I needed that day. I've only got how many thousands left,
Well,
so.
Yeah, well, you never really know, do you? You could go a lot.
No, you don't. Not unless you're cursed with knowing the day of your own death, which is supposed to be a hellish curse.
Blessing too, right? It's not always.
Oh yeah,
if you know exactly when and how you die, that gives you a kind of power as well, because you could do some other wild things before that day.
You go do some, you get real wild. So we'll have to talk about skydiving some other day, though. So great talking with you again, and we will see everybody here next week.